Hello friends, today we're going to work in one of the type of contracts that is very common that will need some time related support. That is an escrow agreement. So for this we're going to open a new contract here. We're going to call it escrow that sold. For this contract we are going to add some solidity functionality here. And then let's start. We're going to call this contract escrow. Yeah, just call it escrow. That's simple enough. And we are going to have a constructor that for the time being we're going to leave empty. Our example is going to work in the following way. We are going to assume that there are two people, a buyer and a seller. So what is going to happen is that at the moment that the buyer buys the goods, is going to submit the price of the goods to the smart contract. We are not going to control what is the price right now because that's a detail, but we are going to receive the price of the goods in the smart contract. We are going to have a flag that is going to be called delivered or not delivered, and then if the flag is delivered, then the seller will be able to withdraw the funds from the contract. If passing a certain amount of time, the flag is not delivered, then the buyer can withdraw the funds from the contract himself because he never received the goods. We also need to have an agent, the one that will verify if the goods were delivered or not. So let's define everything that we're going to need. We are going to need a uint, which is the escrow amount, and let's just call it amount. So this is the amount of ether that will represent the price of the goods. Then we are going to define a uint, which is going to be the expiry timestamp. And we are going to define three addresses. We are going to have an address buyer, address seller, and address agent. And we are going to have a boolean that is going to be called goods delivered. And we are going to do something more. We are going to create a nonce here, and this is just to be able to create more escrows in this contract later on. Let's say that this is a transaction that repeats. So we're going to have another uint here, and this uint is going to be called nonce, like in the Ethereum network. You British guys, stop thinking that much. And then we're going to create a mapping, and this mapping is going to be mapping a bytes 32 to an escrow object. And then we are going to call this one as a private escrow registry. Now we are going to start working in our functions. We are going to have something here that we are going to call function open escrow. And this function open escrow will take some parameters. Is going to have an address that is going to be the seller, so who is the other person that will be able to withdraw the funds. Then it's going to have a time unit. This we are going to use later to be able to withdraw the funds here. So we're going to define actually one enum, and this enum we're going to call time unit. And we are going to say that here we're going to have either days or months as the units of time that will be used to measure the expiry date. So here we're going to define a time unit, and we're going to call it here time unit. And we're going to have here a units, which is going to be a uint. Great. And then this one is going to be external, is going to be payable, but is going to return something. And what is going to return is going to be bytes 32 because we want to get the escrow ID. So we're going to have this function that we're going to call escrow ID here. So that's our main function here. And this function is going to work in the following way. We are going to have the following. We're going to have an address depositor, which is going to be equal to message sender. So whoever is opening the escrow, that's the depositor. And let's not call it depositor. We are calling the other one seller. So this one is going to be buyer. This is going to be purchasing but depositing the amount in the escrow. We are going to have a uint that is going to be the amount. And this one is going to be equal to message value. Then we are going to have a bytes 32 escrow ID. And this one is going to be equal to the following. We want to have some things that we're going to encode. So we're going to have AVI encode packed. And what we're going to encode packed is going to be the depositor and the nonce, which at the beginning is going to be 0. And this is not going to work because this one is not guaranteed to be a bytes 32. So we are going to actually hash it to be contained on that amount of time. So we're going to hash it like this. And this is the way this one is going to work. Now let's do the following. We are going to have, this is still throwing an error. Escrow ID. Have it here. Oh, yeah, I should not declare. This one's already declared. Depositor is the one that's not declared, but this one is buyer. This one should be buyer. So we have everything here working correctly. Now we need to provide the timestamp, right? And this is going to be working in the following way. We're going to have a uint that we are going to call expiry timestamp, and this one is going to be equal to, if the time unit is equal to time unit days. We could use a Solidity native functionality to do this, but since we need to add months and that's not very easy with the native functionality, we're going to go to the Khronus TimeCog library. And here we have libraries, Khronus TimeCog. We are going to copy it. We are going to paste it. And let's just paste that one here. And we're going to do it at the top, and we're going to say import. And this will give us access to the Khronus TimeCog. Now we can use the Khronus TimeCog to add our functionality here for add days. So we're going to have add days, and the days that we're going to add are going to be added to the block timestamp, and we are going to add units. Perfect. Now, if this is not the case, if the time unit is not equal to time unit days, then that's going to be equal to time unit months, right? Which is the other one that we are allowing people to use. So we're going to have this one here, and we're going to have the following. And we're going to have units, and that's it. But this is still not good enough because we're still adding days. We're going to add months. That's what we want to add. So if the user choose days as the unit of time, then we're going to add days. And if they choose months, we're going to add months. And this is working well. Now we just need to populate our function here. We're going to call escrow registry, and we're going to get the escrow ID, and we are going to get the amount is going to be equal to amount. Then the same thing here, we're going to just copy it to make it easier. Then here we have escrow ID, and the other element that we need to create is the depositor or buyer, and that's equal to buyer. Then we also need to have the seller, and that's equal to seller. That one we're receiving as a parameter. Then we are going to have also the other element. We have amount, we have buyer, we have seller, we have expiry timestamp, and that one is equal to expiry timestamp. And then the other one that we need to add is the nonce, and that nonce is going to be increased by plus equal 1. Because after the escrow is created, we are going to increase the nonce, so we're able to create more escrows later on. And that's basically what we need. And this one, we are missing a semicolon there. So this is our escrow. So we might need to get the funds out of the escrow, right? So we are going to do the following. We are going to add a function that we are going to call function withdraw. And in this function withdraw amount, it's going to be external, it's going to be payable, and it's going to return Boolean. This withdrawal pattern is not actually that good. We are just explaining how to deal with time. That's our bread and butter. This function is going to take one parameter, which is going to be the escrow ID, which is bytes 32. And we have our conditions here. So if either of these conditions is true, either the goods were delivered and is the seller that is wanting to get the funds out, or either the goods are not delivered and the expiry already arrived and it's the buyer, then we are going to just send the funds out. So we're going to have payable message sender, and we're going to have a transfer, and then this transfer is going to have the escrow ID that amount. And this is it. Then we're just missing one function, which is the function to deliver the goods. So we're going to have function goods delivered, and that one is going to take also this parameter of the escrow ID, and we're going to have an external function that returns bool as well. Here we forgot to return the value. We're going to return true. And then this one, this is going to be very easy. We are just going to require that message sender is equal to escrow ID, the agent. And then if that's the case, we're going to allow this guy to change the value of the goods delivered. So let's say that we're going to have here a bool that is going to be goods delivered. And then we are going to define that escrow ID that goods delivered is equal to goods delivered. This one is needing other thing here, which we are going to define, and is the address agent. Because if not, we're not going to be able to manipulate the escrow, and then we're going to define, after we define the seller, we're going to do the same with the agent. Now we have the agent. We continue checking that everything is okay. Here we have another error. This should not be like this. This should be like this. It's an assignment. We are going to assign this one. So we're going to redeploy our contract. And here we have our contract. Now we're going to get our addresses. So the second address is going to be our seller. We're going to create an escrow right now. Second address is our seller. The third address is going to be our agent. And then we're going to define that the time unit is going to be months, and we're going to expire in months. 0 is days. This one is months, 1, and then we're going to define 3 months for the expiration day. And then we're going to send and create this escrow. But for that, we're going to be the first account, and we're going to say that we are going to submit 5 Ether. So we're going to create our escrow now. It's creating. We got our escrow, and we need to get our escrow ID. So let's get our escrow ID here. Query our escrow registry, and we have it here. Day 5 Ether. This is the expiration date, and these are the accounts involved. The delivery is false. Right now, if we try to withdraw the amount of this escrow, being the buyer is going to fail because the goods are not delivered, but the contract has not expired. And let's check the expiration date here in our epoch analyzer. This is the current date right now. So let's do this one first. It's September 10. And right now, let's check the date that our contract has as expiration. That was given by this function here, where we are using the Khronus TimeCog. And we're going to put it here in 3 months. So it's working perfectly. Now let's get the funds as the seller, and let's see what happens. So we're going to be the seller now, and this is me. I'm going to be the seller, and then I want to withdraw the amount. And also error because we have not delivered the goods. So let's try to get the agent to confirm that the goods were delivered. So this is the agent, and we're going to need to get the escrow ID, and we're going to say, Mr. Agent, is true, the goods are delivered. So we're going to deliver the goods. These are the goods, and then we got it. And this is because we forgot to make a return here, but that should work. Now let's query our escrow registry. And right now the goods appear delivered as true. So it's working properly. Now let's check as the seller, and let's check our balance is 89 ETH, and let's try to withdraw the amount. And the amount was properly withdrawn. Let's go back here, and we have the amount here, which was the 5 Ether that we had in the escrow because the conditions were fulfilled. So friends, this is the way that you can create a very simple contract that is time dependable with the Khronus TimeCog library. I hope that you have followed and that you find this informative. See you in our next video.